Right, so in this video I'm going to have a look at equations where we have x as the power or the exponent or the index. So I'm just going to do some examples here. So the first example I'm going to do is where we have 4 to the power of x is equal to 8 over the square root 2. So here we can see that our variable here, our x, is a power, and we've got to solve for x. We've got to find what x is. So what we notice here is we've got a 4 here, we've got an 8 here, we've got a 2 here. So the idea behind this is that we've got to reduce all of these numbers here down to the same base. So we can see here that 4 is just going to be 2 squared. So instead of writing 4 here, I can write 2 squared. 2 times 2 will give me 4. And this is the x here. So this is just 4 to the power of x. Over here I can see I've got an 8. Well, that's just going to be 2 cubed. That's 2 cubed. And here we've got square root of 2. Square root of 2 is just 2 to the power of a half. Okay, so now I can see I've reduced all of these numbers here down to the same base, in this case 2. So now I've got to just use the rules for indices to solve this. So let's have a look. Here we have a power of a power, so I just need to multiply these two powers here. So on the left hand side I end up with 2 to the power of 2x. On the right hand side here I've got 2 to the power of 3 divided by 2 to the power of a half. So here we've got to subtract the powers. So I just simply end up with 2 to the power of 3 minus a half. So that's just a power here will be 2.5. Now what I've ended up with here is 2 to the power of something equals 2 to the power of something. So that means our two somethings, our two powers if you like, are the same. These powers here are going to be equal because we've got the same base here on each side. So in other words, down here I'll end up with 2x is just going to be equal to 2.5, 2.5. So just divide both sides by 2, divide this side by 2, I end up with x. Divide 2.5 by 2 and I just end up with 1.25 or 1.25. Okay, so that's the first example. Let's have a look at another one here. So we'll have a look at 2 to the power of x, and that's going to be equal to 2 cubed multiplied by the square root of 2. So again here we need to reduce everything to the same base. So we've already got 2's here. We've got a 2 here, a 2 here, and a 2 here. So we don't have to do a huge amount with this. Left hand side is already 2 to the power of something. On the right hand side we already have a 2 to the power of 3. This here is just going to be 2 to the power of a half. So left hand side 2 to the power of x. On the right hand side we've got 2 to the power of 3 times 2 to the power of a half. So using the law of, or the rules of indices here, we would add the powers. We have the same base, which is 2, so we just write down 2, add the two powers, so 3 plus a half is 3.5. So in this case again we have 2 to the power of something equals 2 to the power of something, so our somethings, our two powers here are just going to be equal. So in other words, x here is just going to be equal to 3.5. Okay, let's have a look at another example. So this is example number 3. Let's take 49 to the power of x, and that's equal to 49 over the square root of 7. Okay, so in this case we need to reduce to the same base again, but if you notice that 49 is just 7 squared and we've got two 49s here, we already have a 7 here, so we're going to reduce everything down to 7 as our base. So 49 is 7 squared, so I can put that here, and it's going to be to the power of x. So this is just 49 to the power of x, same as here. Up here I've got a 49, so that's 7 squared, and here I've got square root of 7, so that's just going to be 7 to the power of a half. Okay, again applying our rules of indices here, we've got a power of a power here, so I'm just going to take that as 2 times x, which is 2x. And here I've got 7 to the power of 2 divided by 7 to the power of a half. So again subtract the powers, the top power minus the bottom power. So that's just going to be 7 to the power of 2 minus a half, which is 1.5. Now again, here we have this 2 bases the same on either side of our equation, so 7 to the power of 2x is equal to 7 to the power of 1.5. So our 2x is just equal to 1.5. So 2x here is equal to 1.5. So again, just divide by 2 to get rid of this 2 here. So we get x on this side. Half of 1.5 then is just 0.75, or just we'll leave it as fractions, 3/4. Okay, let's do another one of these, number 4 here. So here we've got 25 to the power of x, and that's going to be equal to the square root of 125 over the cubed root of 5. So there's a little 3 here. We're going to raise all of this to the power of 12. Okay, so a little bit more involved here, but again, you just apply the rules of indices as we go along. So let's just have a look at the left hand side first. We can see here that we're going to reduce everything down to a base 5. We have a base 5 here. This is just 5 cubed, and this is 5 squared. So we can take 25 as just 5 squared, and that's to the power of x. On the right hand side here, we've got these brackets here to the power of 12. Now we've got square root of 125, so that's just going to be, let's leave the square root symbol there for the moment and just leave 5 cubed here. So in other words, 125 here is just 5 cubed. On the bottom here we have the cubed root of 5, so that's going to be 5 to the power of 1/3. Okay, next line. Here we have again a power of a power, so that's just, you just multiply the 2 powers here, so that's just going to be 5 to the power of 2x. 2 times x is 2x. Now on the right hand side here again we have these brackets here to the power of 12. Here we have the square root of something, so the square root of something is just the something, which is 5 cubed in this case, and it is to the power of a half. So the square root of something is just the something, in this case 5 to the power of 3, all to the power of a half, and that's going to be over 5 to the power of a third. Okay, so let's just move down a little bit here and do the next line. So on the left hand side we still have 5 to the power of 2x. On the right hand side now we have, we'll do the top line here first. So we've got, just put in these brackets again. So we have 5 to the power of 3, all to the power of a half. So again we have these 2 powers here which we just multiply. So we end up, top line here, we just end up with 5 to the power of 3 times a half. Well, 3 times a half is just 1.5. On the bottom here we end up with 5 to the power of 1/3. Okay, so let's continue on. Just keep applying the rules of indices as we go along. So here we've got 5 to the power of 2x. Here we have our brackets again, and that's a power of 12. Here we have 5 to the power of something divided by 5 to the power of something. So when you're dividing, you subtract the powers. So really in here we end up with 5 to the power of 1.5 minus 1/3. We're subtracting the top power minus the bottom power. Top power minus the bottom power here. Okay, so let's just do that. So we have, let me just do it over here. I'll do it in a different color here. So we have 1.5. 1.5 is just 3 over 2, and we want to subtract 1 over 3. So you can do this on your calculator either, but here our common denominator here would be 6. So 2 times 3 is 6, so multiply the top by 3, so that's 9. Multiply 3 by 2 to give you 6, so multiply the top by 2, 2 ones 2, so we end up with 7 over 6. Okay, so in other words, what we end up with here is 5 to the power of 2x is equal to, let me just put that here. So what we're going to end up with is 5 to the power of 7 over 6 in here. 5 to the power of 7 over 6. And again, we still have this 12 on the outside. So all I've done is what's inside the brackets first. Okay, so let's move on to the next line. So we have, let's see, left hand side we still have 5 to the power of 2x. On the right hand side, again we have a power here, so we must multiply these two here. So again I can do that over here. We've got 7 over 6 multiplied by 12 over 1. Well, we can see here that this 6 will divide into this 12 twice, and 2 7s, we get 14 here anyway, so equal to 14. So here we end up with just simply 5 to the power of 14. Okay, so we're almost there. Again, you can see here we've got same base on both sides. Two particular powers are going to be equal. Again, so we've got 2x is going to be equal to 14. Divide both sides by 2, and you get x is equal to 7. And that's it. So that was a much longer question, but again, do it slowly and carefully. Apply the rules of indices, and you'll get there eventually. Okay, so let's have a look at an equation then with where we've got x as our power. So we're going to look at a quadratic trinomial type equation. So let's have a look. What number is this? I've forgotten at this stage. Let's see. It is number 5. This is example number 5 here. Okay. So let me just write it out first. So we have 2 to the power of 2x plus 1. And then we have 15 minus 15 rather times 2 to the power of x. And then we have minus 8, and that's equal to 0. So we're just going to look at solving this equation for x here. Now, what you've got to do here is just take this one here first and just break it down. This is 2 times 2 to the power of 2x. I'll just explain that in a second. Let me just write out the rest first. We're not going to do anything with the rest of this yet. So here you've got 2, if we work in reverse here, this is 2 to the power of 1 here. 2 to the power of 1 times 2 to the power of 2x. You add the powers, you get 2 to the power of 2x plus 1, which is what we've got here. So you just apply the rules of indices here, in reverse if you like. You're just breaking this up into two numbers multiplied here. So 2 to the power of 1 times 2 to the power of 2x is 2 to the power of 2x plus 1. So we've just written this a different way. Now, I'm just going to break this down a further. We have our 2 here times, here I'm just going to change this to 2 to the power of x squared. Again, I'll just explain that in a second. I'll write out the rest first. Okay, so why is this the same? Well, if you take your rules of indices here, you would multiply the two powers. This is the power of a power, if you like. So we have to multiply this x by 2 to give us 2x. So here we end up with 2 to the power of 2x, which is what we've got here. So I've just broken this up to make it look like this. Now, next line. You'll see the reasoning for this now. What I'm going to do is let 2 to the power of x equal to some other letter. Let's say y. We're going to pick y here. So wherever there's a 2 to the power of x in this equation here, I'm just going to stick in a y temporarily. We'll substitute it back out later on. But for the moment, here's what we end up with. We end up with this 2 here. We have a 2 to the power of x here, which is y. We're saying it's y for the moment, and it's squared. Here we have a 15. Here we have another 2 to the power of x, so I'm just going to stick in y here. We have a minus 8, and that's equal to 0. Now if you look at this, this is just a standard quadratic trinomial type equation which you've solved in the past. Easy enough to solve. We have a number of ways of solving this, but let's just do it this way. So we're going to put in our two brackets. We can see here we can factorize the 2y squared into 2y times y. We can see that we have an 8 here. The 8 could be 1 times 8, it could be 2 times 4. I know that 1 times 8 will work here. We need a 15 as well. I know if I put an 8 in here and a 1 here, 2 8s will give me 16, and I have a 1 here which will subtract to give me a 15. So this is going to work here. Now I need a minus, so I need to have two different signs here. I need a minus 15, so I'm going to put the minus here, so I'll end up with a minus 16 and a plus 1 here. So if you check these, you'll see 2y times y will give me 2y squared, plus 1 times minus 8 will give me minus 8, and if I do the ones in the middle here, plus 1 times y will give me plus 1y, 2y times minus 8 will give me minus 16y. If I add these two together, I get minus 15y, and I do have a minus 15y in the middle here, so this is correct. Okay, so let's just move this on a bit again. Okay, so now we have these two multiplied to give us 0, so in other words 2y plus 1 must be equal to 0, or y minus 8 must be equal to 0. So this would give me 2y is equal to minus 1 here, which would give me y is equal to, in other words, I just brought the minus 1 over here, or subtracted plus 1 from subtracted 1 from both sides, yeah. Now here divide by 2, so I divide the left hand side by 2 as well. The other option then would be y is just equal to add 8 to both sides here, so add 8 to this side, it'll disappear, add 8 to the other side, and you get plus 8. So I have two solutions for y here. I have y is equal to minus a half, and I have y is equal to 8. Now remember our original equation here. This is our original equation up here. This is what we've got to solve. We've got to solve for x, not y. But remember, we took out the x. We took out 2 to the power of x, in fact, and we called it y. So in other words, it's going to substitute back in now. We know that y is equal to 2 to the power of x. That's what we decided to make the sum easier to do. So we've now worked out what y is. We know that y is minus a half. So in other words, minus a half must be equal to 2 to the power of x. Or we know that y is equal to 8. So in other words, 8 must be equal to 2 to the power of x. So let's just solve these two then for x. Now we can solve for x. So if we look at the first one here, we have 2 to the power of something giving us a negative answer. That's impossible. We can't raise 2 to the power of anything to give us a negative answer. So this solution is invalid. We don't use that solution here. But what about this one here? Well, here we've got 2 to the power of x equals 8. Well, that will just give me, again, reduce these down to the same base. Well, 8 is just 2 cubed. Here we have 2 to the power of x. So now we have 2 to the power of something equals 2 to the power of something, so that just gives me 3 must be equal to x. So this is our solution here. So in other words, if we put 3 in here and here, multiply it all out and so on, we will get 0 here. So that's it. We found that x was equal to 3. Okay, so that's it for this video.